Orkan Telhan is a pioneer in biodesign. He's a model, I think, a model for future biodesigners. He's an assistant professor at University of Pennsylvania and has a Ph.D. in design and computation from MIT's Department of Architecture. His work has been shown around the world over and over and over again, and it's really a pleasure and a wonderful, just a wonderful moment to have you on stage with us. Orkan has been teaching biodesign with biologist Karen Hogan, one of our judges at UPenn, since we started the Biodesign Challenge. And his classes have been a model for everything that you see here. So thank you, Orkan, for being with us today. I'd like to call you up to the stage.
Let's do height adjustment. Thank you, Dan, for having me. I think it's a beautiful moment now. All the teams are relaxed, you're winning, and it's good to, you're participating in an amazing thing, and now it's time to celebrate all of us, not just the winning teams, but I think it's a great opportunity to be here and share the moments with you. So, as Dan mentioned, I am an aspiring designer, an aspiring biodesigner, but I have been working with design, different kinds of design, for 20-something years. And today, I would like to tell you a little bit of a personal story of how I started with all kinds of design, from graphic design to virtual reality, to sculptures, to bus stops, bananas, breads, all kinds of design. And I ended up in biological design, but it wasn't a smooth journey, but it was a lot of fun, it was a lot of passion along the way. And I just want to inspire you so that you know, after finishing these amazing experiments and designs, you stick with it, so that because you will realize that you will have a lot of say in the future of the world because of what you're doing today. So we have all different reasons to get into design. I was very passionate about graphics, you know, graphic design, and 20 years ago, synthetic biology or microbiome were not the buzzwords. It was Photoshop, right? I mean, it's like a funny thing. Now everyone is like, all these amazing graphics you guys did in yesterday's exhibition, you know, they were all Photoshop. But I was very much interested in, you know, I was tired of drawing. I wanted to really work with graphics, pixels. You know, graphic design had its digital revolution. Now synthetic biology is having its digital revolution, and we are living with it. But I was very much interested in, you know, graphics. But graphics doesn't only mean that you're just making graphics for yourself. It was also about making products, things that you can contribute to the culture, larger culture. This was a CD design that I made to a musician. At that time, I didn't know them that much, but they were famous in, Bauhaus music band was famous in the 70s, 80s. They asked me to design something for them. Peter Murphy was their lead singer, and I had an opportunity to design a CD-ROM for them because I, you know, was early on involved with graphics. So why CDs? You know, CDs are outdated. You know, nobody buys them anymore. You keep vinyls. This is an old one. But it's very important to see your designs circulating in the world and going beyond your computers and be part of culture, right? I mean, this is music. This is how we share things, and this is how we, you know, participate in the larger whole that we're part of. Nobody buys CDs anymore, but I just saw this the other day. If you really want a product, you know, if you really want to attach that, you can spend $200 to buy the piece of plastic that carries ones and zeros. But now we don't do this anymore because we stream data, we have iTunes, we have Spotify. So we've been digitizing our content. Remember, the digital revolution that allowed us to stream music has been around for a while, but we are also entering into the digital revolution which will stream our biology from the microbiome to our cells into different places. So keep all of this in mind in a big continuum of things. So this is early 2000s. It wasn't only just Photoshop. This is a time of, you know, for the architects and the landscape architects, product designers around us. This is also how we start working with tools that were becoming accessible for us. 3D printers were becoming available, you know, all these CAD tools. You know, I was part of a team designing, that was asked to design the future of a bus stop in 2006. You know, I was the graphics person. They were saying that, okay, why can't we just design something for, design a screen for a bus stop? Can we put some graphics into it? And I realized that was a moment for me to really question a lot of things about what I know about graphics. So here I pause and make you. I'd like you to think a little bit about when designers, artists, educators, engineers start to build their own technologies. Because now with Biodesign, we are actually getting involved with designing our own technologies. Designing technologies allow us to really become critical thinkers. It allows us to really challenge assumptions. It allows us to really look at, like, why the hell the screens should be really rectangular? Can they just be wrapped around? Can they just be bidirectional, three-dimensional, flexible, and so on? So I was really playing with software, hardware, making my own pixels. But the main lesson was that don't take anything for granted. Even if you're building graphics, even if you're building, programming organisms or working with cells, there's nothing granted. You can always challenge assumptions, and that makes us designers. We don't really take things for granted. So, these tools, these different ways of looking at things, made me also realize that there's really no such thing as a genre for design. It could be graphic design, it could be product design, you can design bus stops. It's all about having access to the right tools and the right framework so that we can imagine things. So we don't really have to confine ourselves to be an architect, product designer, or a biodesigner, because it's all about your imagination at the end. And in 2010, something magical happened. When I was, trying to learn how to program microcontrollers and such, somebody tapped on my shoulder and said, by the way, you can also, program cells. You can put DNA inside an organism, and you can make really your own organisms. What do you mean making your own organisms? Well, there's a thing called the cell-free protein synthesis. You can really make oil droplets, put DNA inside them, and voila, you have your artificial cells. And this was a groundbreaking moment, because it's the time where you really think about, oh my God, I'm learning new things about software and hardware, but you can actually create your own cells, artificial cells, protocells. And as a designer, I was, embarking in a mission of becoming, doing a Ph.D. in design. And design is not only about just learning about new technology, but you also look at its history. You start theorizing things. I was in an architecture department, design and computation. I looked at the history of, how the people were thinking about architecture, because now we can make cells, the first level, building blocks of our life, which are very much like cells in architecture. There's a history there, enclosures, buildings, urban theories about thinking about life in different kinds of embodiments. You really realize that everything is still in a continuum. So even if you learn the latest technology in synthetic biology, it comes with a lot of history. So you learn a lot of, and not only learn about history, but also learn about how different fields deal with history, and learn how to do experiments. So one of my main things in doing my PhD was that I learned how to work with the scientific method and explore the way how scientists work with the same material. So it's very important not to just take the technology, but also the way of working and the way of thinking with things. 2010, also 11, was an important moment, also here to pause a little bit about and to think about these things when we work with new technologies. I went to Australia, and I also learned about the urgency of things. When you're in your little lab, when you're working on new kinds of technologies, you realize that sometimes you don't really pay attention to what's happening in the world. There's a lot of disasters, ecological disasters, environmental challenges happening. So I went to Australia, and I saw this amazing big landscape, acres of sandalwood trees that Australians were planting because because sandalwood trees were actually becoming endangered species on the continent. So you may think that, well, why sandalwood is important? Well, if you're using perfumes, if you're using soaps, different kinds of cosmetics, there's tons of sandalwood trees every day that's been chopped, that's been extracted for their oil, that's extracted for the different compounds inside them that you consume on a daily basis. So our habits actually, we don't think about how much how much trouble they cause to the environment, but sandalwood is now an endangered species. And very much like whaling in 1920s, Australia finished almost all of its wild sandalwood stock, so they've been planting new sandalwood. So why is this important? Well, it is important as much as as elephant tusks are or other endangered animals are. People are illegally logging trees in different parts of the world because there is so much demand on it, and one log of sandalwood is pretty much the same cost of AK-47 machine gun. If you make those comparisons, it's big business, and people are losing their lives because they're logging illegally and they're hunted down by the officials. So biological design, it helps you start to think critically and very carefully about certain kind of assumptions. I was thinking about how you can overcome this problem. How can you challenge this by thinking about, okay, instead of growing all this oil inside, with these trees, can we find a way to really synthesize these compounds using microorganisms so that you don't have to kill these trees. People don't have to lose their lives, so you can have an abundance of production, biosynthesis. So the people in Australia that I participated in their research, they were really looking at this whole problem of approximating the sandalwood oil, by looking at the genes from the plants, and can you take these genes and put them inside these organisms, mainly yeast and E. coli, so that you can produce them in large quantities. Again, an abundance of production, microbial labor, which you can actually feed sugar and then eventually get a lot of sandalwood out. Now, we use this methodology a lot these days in different fields. And if you think about what is common in all of these design practices, how we start from basic research, whether it's biological design or making a CD or making a bus stop, we work with a lot of existing research, and then we start as designers prototype them into different kinds of applications. We make shoes out of them. Alginate makes shoes things. We have food designers that work with food, working with new kinds of compounds. We have people who work with biosensors, the same kind of processes, and then things go into production, large production, into fabrication. Our work needs to circulate in culture so that we can actually make some impact to it. It's not about mass producing for consumption, but more also like shaping culture and societies that we are living in. So as a designer, I like to think about this work in this big framework. And I also start to think about, we don't do these things alone. We are a community. We have to work with these things together. And it's also important to really participate in other communities. So I formed a company a couple of years ago with a couple of very good friends. And we started to really think about how do you make all of these very accessible to other people. So, remember, your design skills, whether you're in a design school or in a company, are all limited by the tools that are accessible to you. If you have the tools, if you have the Photoshop, you can make all the graphics. If you have the 3D tools, you can make all the amazing products that you like. But if you don't have the biological tools, you cannot really actually grow, do things in a good way, in an effective way. So last year, we started to do a mini project with Puma, because they were interested in getting in biological design. But we had something very special in mind. We didn't want to do something that is all about making sustainable products, but think about how do we really embed live organisms inside apparels, inside wearables, so that these live organisms can actually integrate to our bodies and different kinds of processes. So obviously, this wasn't so easy. We had to develop some tools so that Puma designers can work with us. We did a collaboration with MIT. We write some special software. Same kind of processes to do, different, which I did for the bus stop. You develop the tools so that other people can actually collaborate with you. And ultimately, we exhibited everything last March all together in the Milano Design Week. So this was an important thing because the work that was created in the lab now found a place to go outside and actually have some impact and inspire other people. So I'll tell you a little bit about the projects, because it's important to think about them as not as prototypes or products, but more like experiments, because you have to be humble about what you achieve in a short period of time. So let me show you a little video. This is a new kind of fabrication method that we imagined for fabricating new kinds of sneakers. So you embed live organisms on the surface of a sneaker, which starts to consume the surface in a particular way, so that you can actually have a particular pattern that is emerging out of it. So subtracting out the parts from an existing form with the live organisms on it. So it's not a material that is produced before and then applied onto the shoe, but actually being eaten alive while you're actually working at it. So depending on how you sweat, depending on how your foot heats, actually changes the way, the kind of pattern that grows on the shoe. And if you think about it, everyone starts with the same kind of shoe, but then everyone has a very personalized look and feel afterwards. But if you think about it, this is not just a product. This is not about just making a design, but imagining a different kind of fabrication technique that other people can utilize. So it's all about, imagining, as a designer, a new way of thinking about how you make the material, and then letting other designers use it for all kinds of other applications. That's how we actually contribute to, pushing design disciplines forward, as opposed to just making products out of it. So I will talk about one more project. This was basically a bunch of biosensors that we designed for T-shirts. So imagine you're a runner, you go outside, and if the air quality is bad, you don't want to run and consume, take a lot of the pollution. But so you have a sensor on your T-shirt that actually detects the amount of carbon pollution in the environment, and basically changes color so that you can be informed during your run. And these are all realized prototypes that actually work, so that we have runners running them and testing them out. Again, embedding live organisms inside the clothing so that they're not manufactured before and applied later. They're all live as we speak. There was a lot of experimentation process, not with the biology itself, but how do you integrate biology into the design so that you create a new kind of integration between them. Because it's very important to bring your own skill set into the picture. So whether you're a product designer, architect, or a graphic designer, your sensibilities actually really matter when you work with scientists, when you work with different kinds of bioengineers in the process. And here how it looks like, the final thing. So these days, and I like, Christina posed a couple of questions yesterday about why design, why biology. I want to follow up with that. Why biological design? These days, I'm working with bread. I'm working with an entirely different medium, because I think bread is one of the most cutting edge technologies that we have developed in the past 1,000 years to 3,000, 4,000 years. And I'm interested in bread because it's actually something that really combines a lot of things about history, future. I look at how you can actually embed new kinds of organisms inside bread so that you can actually program the microbiome of your own body. And from a nutritional perspective, or also from a sociopolitical perspective, the way it changes the hormones and the identity of your body. But more importantly, why biological design? Because biological design, like food, like bread, is ultimately something that is really very connecting. That is really actually making the basic parts of our lives. So what do I mean? The image that you're looking at is, the familiar image from the Tahrir Square, the Arab uprising. And you may think like, oh, what does it actually have to do with anything with bread? But actually, if you look at the history, one of the reasons why the Arab Spring started was because of the wheat prices and the bread prices in Tunisia, because they were doubling up every 6 months, and that caused a lot of uprisings. So why is this important? Because everything that we do in this room, whether it's about food, about new materials, about new ways to think about design, will have a lot of impact in the future. And these are very difficult problems that we are tackling with. We are dealing with the environment, we're dealing with food security, we are dealing with pollution. These are hard problems, but we are a growing small community, and we are at MoMA. This is the right place to do it, because this is where a lot of design movements have started. And actually, we are going to really succeed. If we really succeed in this, we can really make a big difference. And I end with this and wish the remaining teams a very successful day.